Okay, supposedly this is working. I've done 4 videos. I'm not seeing them show up. But hopefully you'll see this demo for the math solutions, figure 2-5. And again, people helping me demo this will get some bonus points. So take a quick glance at this. We need our general notes. This is a ANSI drawing, so it has got to be 2 places. This is 0.875. I know that because I'm very familiar with my fractions. I know that this is 5625. I know that this is 375, meaning that this is 3/8. This is 9/16. Okay, so 875 is 7/8. 0.25 is a 1/4 inch. 0.38 again is 3/8. So that's what I was looking for when you submit this and figure out the fractions. What are the decimal callouts have to be for the fraction callout? ANSI ASME drawing calls out specifically for decimal callouts. So understanding your fractions and your transitions from the decimal to fractions is imperative. This leader needs to be on all 4 views. I want the datums on all 4 views. I'm looking at this. I don't think that this is laid out correctly though. This top view should be upside down. So I wouldn't go changing it now, but in reality I'd blow out the ISO view and then don't worry about it. But this probably would have been better if this view were down here and then projected that up. Or you could have a top view. In reality I'd probably just have a top view and a side view for the thickness. But I'm trying to get you guys to lay out all 4 views because I want to see where your datums are or where you think the datums are going. So we need to add my name is checked in the designer. Oh, in this case will be me. I need weight in pounds down here. And then the number is strictly this number here. That's your drawing number, and this is our title. Okay, so we need to add the general notes, the flag notes, the datums on these views. Now, all that being said, here's what I would change differently. If this is datum A, these 3 dimensions got to come from datum A going up. You told the shop to measure everything from the bottom, but our measurements are all coming from the top. And datum B would really be this left side over here or this right side over here. So that would determine how I lay out the dimensions horizontally here. What I would do though is I would dimension from this hole to this hole, and then I would chain dimension from here to here, or I might dimension from this hole here to this hole here. Okay, and then I would dimension, this one would stay, this one goes, and I dimension from this hole to this last hole, which means I know the distance from one hole to the next, and then I can control that from here to here, allowing for less tolerance buildup. I can see no dimension lines in here, so this 0.56 needs to come down and out with the shoulder. Now you may have said, well, the book did it this way, but the book doesn't know anything about dimensioning. They're just laying out a view so you can make a part. You're the one that has to determine what dimensions need to be there. And this dimension has to move up to line up with this arrowhead. We need to have extension lines on both ends. And I can see why. You got this going through here and you're trying not to cross. Sometimes there's just nothing I can do about it. Okay, so far everything else looks good. make those submissions for your bonus points. Okay, now here we are stack dimensioning, and they kind of follow suit with what I've been talking about. To do your engineering ISO views, we've covered this, where you got to go into creating the drawings. Creating drawing quick references. There's a video called Isometric Views to go in there and look at. I would move this up. Okay. I probably would have went twice scale, just because it's so tight to get all these dimensions in here, because this dimension has to come out. This 0.88 should be chained with this one, and this 1.25 should be coming off the datum. We probably should be dimensioning this from the datum. This must have a shoulder, so you have to click on it and grab the arrows, the white arrowheads above, and move it to the right to make room for the shoulder. And it's not X3, it's 3X. And it has to have a single arrowhead. This has to be num-dinked. I would move this up here, so again, this isn't crossing. You literally could just put the -5 and not have the -2. Okay, so again, the ISO view needs to be laid out per directions in the video for doing ISO views. I feel like this, if I were to go to the engineering ISO view and click on that, this is not the orientation I would have. And when I look at this doesn't really line up with that. Now, I like how you did a section view. That's a very good way to do that. But these aren't in fractions, so I know that the directions, we were saying something about fractions somewhere. But what we're trying to get out of that is you would figure out what the fractions have to be decimals. Oh, I want to say there was questions on this that had to get answered. And I know Aaron usually does a good job of doing that, so let's see what he's got here. Okay, so these were the fractions. What I need to know is, what are they in decimals? Okay, so the decimals is what we got to call off on the actual drawing. We can't call off fractions for ANSI-ASME specs. That would be more for architectural or civil design. Oops. So in reality, this notch here would be kind of more over to the left, according to how this is set up. When you guys are doing your orthographic views, ideally, if I see this view, and this view, those should be the views I'm looking at. It's a tough one to explain, but when you hit your ISO view, it should clock it in that view. So again, if you watch that video on creating the isometric views, you can really only do it one way to get it to work right. This should have to flip all the way around though, because yeah, how it's laid out, because this should still be fine doing the section view. And I'm seeing that right side view, but the clocking of this isn't quite right. It's not something I want you to make a change. I don't need you to redo it. I don't want it to screw up your drawing. If it's going to take too much time to fix that though. But these all got to be changed to num-dink. Okay. This, hard to read in here. This line comes from the rev block down to here. All that stuff is crossing, so we would have to adjust accordingly. See, this datum C is right on this same edge here. And it gets confusing to the shop. What we want is the datum, so we got to move this up here where I'm not touching any other lines other than just this vertical line. Or again, the answer is to pull it straight up off the part. Alright, I talked about this is datum A. So if this is datum A, these dimensions should be coming from datum A instead of from the top. This dimension here should line up chained up with this one. This one really should be coming from datum B. For tolerance buildup, I would try and dimension from this hole to this hole, keeping all my holes tight with each other. So it's a little bit trickier to dimension just because of how it's laid out. You'll see a lot of people stack dimension it, but you got to remember the tolerance build up when I stack or chain dimension this. I really want the holes to work with each other, which is kind of what we're doing here. Actually, I would remove this 0.5 dimension and then just have the dimension from this hole to this hole. And then this dimension would go to the center hole, and then everything's just going to kind of line up based on this hole in the center. I think when I was talking about that, it'd be the same thing here. We could get rid of this dimension and just put this dimension here, chain those up, and then we got tightness between our holes and the hole location here. Oh no, I'd really want to go from hole to hole. So it is kind of a mess to try and get in there and do that. But that would be your best technique, from outside hole to outside hole, inside hole to another inside hole, to keep them all tied up tight. So again, I would remove this dimension and go from outside hole to outside hole. This is fine. I know I kind of would prefer to do this whole dimension and then outside hole to outside hole. It is get kind of messy, so I could do dimension from this hole, then the first hole to the last hole, and then one dimension from one hole to another to tighten up the tolerance between the holes. Same thing on this one. For your hole spacing, if you go twice scale, it's going to make it that much easier to get those dimensions in there. Okay, this one again, we don't want to be in fractions. This one I can't do because I'm dimensioning to a T. Right here, we don't want to dimension to that T. It's great that you guys did figure out how to do fraction dimensions. Yeah, I want to remove this dimension from the first hole to the last hole. Tighten up that tolerance on that, and that would be good. We can't dimension to this because there's a T here. We would have to dimension here where I can actually see the feature. Okay, so datum A should be this bottom line. Datum B should be this vertical line, and all your dimensions should come from the datum. Okay, so your datum should be lined up more like this here. Okay, hopefully that will help for anybody struggling with this math solution 2-5.